Well, you see, there is a moment just before a story begins when the universe seems to lean in a little, as if inviting us to listen. And tonight, I suppose I want to begin with a simple question that might, well, linger with you long after the words soften into the quiet. What if a lone visitor from the deep dark between the stars drifted past our little world, not just to pass us by, but also to remind us that we might simply be standing on the roadside of a far older journey? You can almost picture it gliding through the vastness at 40 kilometers a second, a fragment shaped by billions of years of cosmic weather, carrying mysteries etched into its surface like ancient runes. And that is the thing. When an object like 3I Atlas arrives, moving on a path that will never loop back, we cannot help but wonder whether its story began in some forgotten corner of the galaxy, or whether it began in an environment unlike anything our solar system has ever known. As it slipped through our celestial neighborhood, its behavior whispered riddles, so subtle in its deviations. Tiny shifts, strange alignments that didn't quite match what the textbooks expect. Its faint light flickered with clues about chemistry sculpted by time itself. And there is a kind of humility in facing something that refuses to reveal itself fully. Science thrives on data, but sometimes, as with this wandering shard of interstellar history, the best we can do is follow the traces it leaves behind. Hints, shadows, questions that stretch not just our instruments, but also our imagination. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim is simple, not just to share science, but also to help you drift off to sleep while exploring the quiet wonders of the universe. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. And, well, let's continue. Well, when we first turn our eyes toward the path of 3I Atlas, we find ourselves staring at something that feels both familiar and impossibly distant. A trajectory is, on paper, just a line, just a curve, plotted against the gravitational pulls of the solar system. But this one seemed to whisper that there was more beneath the mathematics. And when we look at that path, we begin to see not just motion, but intention. Not intention in the human sense, of course, but the kind of cosmic storytelling that emerges when an object has wandered for millions of years, sculpted by collisions, by radiation, by ancient histories we no longer have access to. The orbit of this visitor was already unusual when first observed from Earth. It arrived on a hyperbolic path, so steep that even the earliest simulations suggested it would never return. Once it slipped past the sun, it would be gone forever, passing out of our planetary neighborhood and back into the galactic tides that shaped it in the first place. And that alone makes it rare. Only a small handful of objects traced paths like this. Oumuamua, Borisov, and now this quiet traveler making its exit at 40 kilometers each second. But then the interplanetary data came in, and the story grew deeper. From two vantage points far from Earth, the instruments aboard the Trace Gas Orbiter and Mars Express captured 3I Atlas at moments when the geometry between Sun, comet, and observer shifted in ways impossible to replicate from a single world. You can almost imagine the two spacecraft orbiting Mars like patient watchers, waiting for the object to slide across their line of sight. And well, with those dual perspectives, the orbit was refined, the angles tightened, the uncertainties shrank, and what emerged was not just a hyperbolic path, but a path aligned in subtle, curious ways with our own ecliptic. Not perfect, not exact, but close enough that astronomers began to tilt their heads and wonder why. That alignment is not just geometry, it is a low probability event. Not impossible, but uncommon enough that it makes you pause. So what does that mean? Perhaps nothing, perhaps coincidence. But coincidence, when paired with other oddities, begins to feel like a pattern waiting to be understood. We grow older, clocks tick, and suddenly we find that the universe still enjoys surprising us when we least expect it. And as the orbit unfolded in simulation after simulation, something else stirred beneath the data. The motion did not simply follow a gravitational curve. There were tiny departures, tiny deviations, as if the object were being nudged by invisible hands. Non-gravitational acceleration is not unheard of. Outgassing from comets can create a gentle thrust. Jets of sublimating material can push a nucleus this way or that. But here, the magnitude, direction, and persistence of the acceleration did not quite match the usual expectations. And when something does not match expectations, it forces us to rethink the story. Imagine, if you will, a highway stretching across the galaxy. Not a physical road, of course, but a tapestry of gravitational potentials, stellar movements, and galactic geometry. Most interstellar objects wander without purpose along these enormous gradients. Their paths are decided not by desire, but by ancient interactions, the lingering scars of collisions, the gentle drifts imparted by close stellar encounters. And, 3 I Atlas seemed to be following one of these invisible lanes. The direction it entered from and the direction it exited toward suggested a kind of flow, a vector that pointed beyond the familiar neighborhoods of our own star. Now, it is tempting to think that such a path means something deliberate, something that hints at intention. But science requires, a pause, a breath, a reminder that trajectories are the stories of past forces, not necessarily present motives. Even so, the idea of a galactic highway carries a poetic truth. Space is not empty. It is shaped by gradients and histories we do not always see. And by placing 3 I Atlas within that vast map, we begin to sense how our solar system is not an isolated island, but a coast visited occasionally by travelers from deeper waters. As the data continued to accumulate, researchers began looking for analogues. Oumuamua came first to mind, of course. It also displayed non-gravitational acceleration. It also carved a trajectory that ignored the sun's pull more than expected. Borisov too drifted through on a hyperbolic path, though far more like a traditional comet in behavior. But neither fully prepared us for the mixture of features, the blending of comet-like and comet-unlike that defined 3I Atlas. And that mixture always brings with it a sense of curiosity. It's not a simple question of what it is. It's a question of what it has become over the unimaginable stretches of time it has endured. You see, in 2025, when the refined orbital solutions were made public, researchers pointed out that the motion could be interpreted not just as a pass through our system, but as a continuation of an older route. Hyperbolic orbits are, by definition, unbound. They do not loop. They do not return. And something about that is strangely poetic. It's not coming home. It's not even visiting. It is simply drifting through, as if our star were just another lighthouse seen from a ship that does not intend to dock. And so when we look at such a trajectory, we cannot help but wonder where it began. not just what star it came from, but what event set it free. A collision, a gravitational slingshot, the dissolution of a long-dead planetary system. In the beginning, well, perhaps it orbited peacefully around a distant sun, but stars age, worlds fracture, tides shift. Whether it still remembers its origin, well, whether it exists at all as it once was, is another question. Objects like these are survivors of deep time. They carry no identity beyond what we infer. Yet their paths are written by histories so ancient that we can only imagine them in metaphors. So as 3i Atlas swept past the Sun, the question emerged naturally: is the orbit simply a relic of its past, or a clue to something more? The more refined the orbital elements became, the more they hinted at subtle structure. The object came in along a direction not far from the solar apex, the point toward which the Sun and its planets move through the galaxy, and that invites reflection. If the Sun is ploughing through interstellar space like a boat pushing through water, then perhaps objects like 3i Atlas represent debris caught in the currents we stir. It's not intention, it's not design, it's just physics acting across unimaginable scales. But even that simple idea carries wonder. It means we are not merely observing the universe, we are moving within it, leaving wakes, tracing invisible arcs that shape what visits us. The data from Mars orbit added layers to this story. With 2 separate spacecraft capturing the object's brightness variations, observers could triangulate not just position, but aspects of its rotation and outgassing behavior. If you imagine holding a small pebble and attempting to deduce its history from its surface patterns, you begin to understand the challenge. Yet in space, the light curve becomes our only map. Peaks and dips in brightness reveal moments when jets of material rotate into view. And for 3i Atlas, these jets were not symmetrical, they were not evenly spaced. They hinted at a strangely shaped nucleus with uneven distribution of volatiles, and uneven volatiles lead to uneven acceleration, nudging the orbit in directions that gravity alone cannot. But this unevenness, well, it was not enough to explain everything. The trajectory still contained small mysteries, and that is often how scientific understanding evolves, not with grand revelations, but with small, stubborn mismatches between model and observation. It's not that physics fails, it's that nature insists on being more intricate than our equations first allow. As astronomers compared the path of 3i Atlas with Oumuamua's, a quiet pattern began to take shape. Both objects entered the solar system from directions strangely aligned with broader structures in the galaxy, not exact, not definitive, but suggestive. And patterns, even tentative ones, draw the mind toward questions larger than the immediate data. Are there preferred paths along which interstellar debris tends to travel? Are we sampling a population of objects shaped by similar cosmic forces? Or, well, are we simply observing coincidences that vanish when the next object appears? That uncertainty is not a flaw, it is the engine of curiosity. And as we follow this object's route toward the outer reaches of the solar system, we begin to feel the subtle shift from the realm of measurement to the realm of imagination. Trajectories tell us where something is going, but stories tell us why we care. And I suppose what draws us in is not just the arc 3i Atlas traced across our sky, but the sense that this arc is part of a much older journey, one that began before our species existed, one that will continue long after our civilization changes, grows, or fades. The trajectory also hinted at something else, something that resonates with the human desire to make sense of fleeting encounters. Objects like this remind us that we are not at the center. We are simply one waypoint among billions. And that perspective has a kind of soft, humbling power. It's not that we are small, it's that the universe is vast. It's not that we are unimportant, it's that importance isn't measured on cosmic scales. What matters is the wonder we bring to the observation. So as 3i Atlas continues its outward journey, leaving behind the pull of our star, the path it follows becomes a bridge for us, guiding our thoughts toward the deeper layers of mystery. Because the orbit is only the first clue. Beyond it lie the anomalies that paint a richer, stranger portrait, the alignment, the anti-tail, the odd chemistry, the deep negative polarization. These form a tapestry of questions that push us to look beyond the simple gravitational plot. And as we step from the clean geometry of its trajectory into the more textured world of its physical behavior, we begin to encounter the 8 anomalies that puzzled astronomers and stirred debate. And that, leads us naturally into the next part of this story, where those mysteries deepen and the familiar rules of comets begin to blur. Well, when we step from the clean geometry of the orbit into the deeper forest of anomalies, we find ourselves in a place where the familiar rules of cometary physics begin to blur around the edges. And, that is where the story of 3i Atlas becomes something more than just a passing visitor. It becomes a puzzle that stretches our understanding in 8 different directions at once. Not wild directions, not sensational ones, but subtle ones, quiet deviations. And those are often the most revealing, because they force us to ask whether we are seeing nature as it is or nature as we expect it to be. The first thread in that tapestry is the ecliptic alignment. It seems like such a small detail at first, just a gentle tilting of the object's path close to the plane in which our planets orbit. And yet, the probability of such an alignment happening by chance is low. Not vanishingly low, not impossibly low, but low enough that it made astronomers pause. We tend to assume that interstellar objects blown free from distant stars should come at us from random directions, arriving like seeds scattered across the galaxy. And here was one that seemed to whisper, not random, not just a stray stone thrown across the cosmic pond, but something whose past may have been shaped by a chain of events aligning it with our solar plane. So the question naturally formed, was this alignment simply coincidence, or was it a fossil trace of some earlier gravitational encounter, a stellar wind? A close pass by a massive body billions of years ago, the alignment does not claim an answer, but it offers the first hint of the complexities ahead. Then comes the anti-tail, the strange jet that seemed to point toward the sun instead of away from it. And you see, an anti-tail is not magic, it is geometry, a play of light and dust and perspective. If the dust grains shed by the object are large enough and arranged in the right plane, the sunlight scatters in such a way that the tail looks reversed. And, that has been seen before, rarely, briefly, in very specific comets under very specific alignments. But in 3i Atlas, it lingered, it persisted in a way that made observers squint at their data and run the calculations again. Because the antitail was not just reversed, it was oddly stable, almost as if the dust were being organized by something more structured than chaotic outflow. It's not that it was unnatural, it's that it was uncommon. The kind of uncommon that leaves you rubbing your chin, wondering what combination of rotation, jet activity, and grain size distribution could produce such a clean directional signal. And this leads us onward to one of the most debated features, the non-gravitational acceleration. Um, if ordinary comets behave like kettles warming on a stove, venting jets of vapor that push them slightly off their gravitational path, then 3i Atlas behaved like a kettle with mismatched whistles, each blowing at odd intervals with intensities that didn't quite fit the expected thermal models. Outgassing can explain some of the push, yes, but here the acceleration was stronger than typical, and more importantly, it was difficult to model consistently. Scientists attempted to fit curves. They adjusted assumptions. They tried different distributions of volatiles beneath the surface. But the resulting models, while close, often drifted away from the observed reality. And that mismatch is what drew attention. Not because it hinted at something impossible, but because it hinted at something unknown. A thermal structure we do not yet understand. A surface that may have been processed by cosmic rays for so long that traditional comet models simply do not apply. It's not just that we're missing information, it's that we're missing a vocabulary to describe what we're seeing. The next anomaly felt almost like a whisper from a different field entirely, the nickel emission without accompanying iron. And, well, that is strange, because in most astrophysical environments, nickel and iron travel together like old companions. They condense at similar temperatures. They evaporate in similar conditions. They are siblings in the stories of dying stars. So seeing nickel without iron is like hearing a duet where one voice is inexplicably absent. Some researchers noted that nickel-rich compounds can appear in certain industrial processes on Earth, though they were quick to emphasize that such comparisons are metaphorical. But the oddity remains. If nature has forged a way to separate nickel and iron in interstellar space, then it has done so through a mechanism we have never witnessed directly. And that is a compelling mystery, not just in the sense of curiosity, but in the sense that it may point to an entirely new class of interstellar chemistry shaped over billions of years. We continue onward to the low water content. You see, comets in our solar system are usually rich in water ice. Some are dusty, some are fractured, but water is nearly always there in abundance. In 3i Atlas, the amount of water detected was astonishingly low, not absent, not zero, but low enough that it suggested an origin far from environments like ours. Perhaps in regions where water ice is unstable, perhaps in zones where radiation strips volatiles long before a nucleus can mature. So if the first anomaly hinted at a strange trajectory, this anomaly hinted at a strange birthplace, a cradle so different from our solar nursery that the object carries the signature of an entirely different history. Then we encounter something subtle yet powerful, the deep negative polarization of its scattered light. And polarization is one of those quiet measurements that rarely makes headlines, but often reveals the hidden architecture of dust and surface composition. A negative value near -2.7% signaled a surface coated in grains, unlike those found on typical comets. Perhaps extremely fine, perhaps layered, perhaps fractured by countless epochs of cosmic ray bombardment. It's not that the reading was impossible, it's that it was rare. Rare enough that astronomers pulled up catalogues of past comet observations, comparing curves, searching for analogues, and finding very few matches. The surface of 3i Atlas seemed to be telling us that whatever it once was, time had sculpted it into something new, a relic altered by eons in interstellar darkness. And then um, almost like a cosmic coincidence brushing against human imagination. We find its incoming direction overlapping with the patch of sky associated with the old WOW signal detected decades ago. And, um, well, this is where scientific humility truly enters, because the human mind loves patterns, loves connections, loves the idea that two mysterious things may be related, but the overlap was broad. The WOW signal was never repeated. And astronomers were careful, very careful, to emphasize that this was almost certainly just a chance alignment, a reminder that the sky is vast and our ability to recognize coincidences far exceeds our ability to interpret them. It's not a clue, it's a lesson. A lesson that coincidence is not causation and that we must tread gently when imagination runs ahead of evidence. Finally, we reach the perihelion timing. Um, some observers noted that the objects closest passed by the sun aligned with a window when an O-berth maneuver would hypothetically provide high efficiency for a spacecraft. And while, well, it is an intriguing overlap, it is not evidence of anything deliberate, because the O-berth effect is simply physics. It works for anything using thrust near a gravity well. And 3I Atlas, lacking engines or intent, has no reason to optimize anything. But even so, the coincidence invites at least a reflective moment, not because it suggests intelligence, it doesn't, but because it reminds us how easily our minds project human frameworks onto cosmic processes. We grow older, clocks tick, and with every passing year, we find ourselves more aware of the stories we tell as much as the facts we gather. So when we take these 8 anomalies together, what emerges is not a declaration of the extraordinary, but a picture of complexity, a picture of a world shaped by forces we do not yet understand, not just one anomaly, but 8, not just one question, but a constellation of questions. And in that constellation, the beauty lies not in the answers, but in the pursuit, because this is where science lives, in the space between data points, in the subtle curves that resist easy explanation. We find ourselves asking whether 3I Atlas represents a new class of interstellar objects, or whether it is simply an outlier shaped by an unusually long and hostile journey. The fact that so many rare features cluster within a single visitor makes it something of a cosmic case study, a kind of natural laboratory drifting past us at 40 kilometers each second. And yet, even as we lean closer, the object recedes, literally, figuratively. It does not slow down to answer. It does not wait for us to decode its secrets. It simply moves onward. And perhaps that is what draws us deeper into the next layer of the story. Because if anomalies raise questions, natural models attempt to answer them. And in the work of researchers who sought to explain these features, not with extraordinary causes, but with the resilience of ordinary physics, stretched into unfamiliar territories, we find the next chapter taking shape. The chapter where we turn toward the models, toward the simulations, toward the attempts to reconstruct how a shard of interstellar material could behave so strangely and yet still belong entirely to the realm of nature. And, well, that invites us gently into the following exploration, where the efforts to model the outgassing, the rotation, and the thermal properties of 3I Atlas begin to paint a picture that is not simpler, but richer, leading us further into the quiet complexity of Chapter 3. Well, when we step into this next layer of the story, it feels as though we are leaving the crisp outlines of observation and walking into a workshop where scientists gently try to stitch together a picture of what this strange visitor might truly be. And well, that is where the natural explanations begin to take shape. Not explanations that close doors, but explanations that open them a little wider. Because after 8 anomalies tugged our curiosity in 8 different directions, the question became simple. Can nature, stretched far enough across time and distance, account for all of this? Or, well, whether it can exist at all in a form we recognize. So this is where the work of Florian Neucart and others enters gently, almost like a quiet voice in a room full of speculation. Neucart proposed a Monte Carlo thermophysical model, something that tries to simulate how heat moves through an object, how volatiles escape, how rotation shapes the thrust that outgassing can produce. And although the name of the method sounds complex, the underlying image is beautifully simple. Imagine holding a small sphere of porous ice and dust. Now imagine that sphere spinning slowly, and imagine that beneath its crust are pockets of trapped gas. As sunlight warms one side more than the other, jets of vapor burst out through small cracks. And these jets push. They push gently, irregularly, and often unpredictably, not just in one direction, but also sideways, also diagonally, also in little bursts that depend on rotation, sunlight, and internal structure. It is like imagining a tiny world breathing. Not breathing like an organism, of course, but breathing in the sense of cycling energy in and out. And if we follow that breath across millions of possible simulations, we start to see how non-gravitational acceleration might arise in ways that look strange from the outside, but are perfectly ordinary inside the physics. The Monte Carlo part simply means randomness, or rather, controlled randomness. Thousands of possible internal structures, thousands of possible jet configurations, thousands of possible rotations. And in some of these simulations, the resulting motion looks very much like what 3i Atlas displayed, a complex, shifting, anisotropic outgassing pattern that pushes the object in ways that gravity alone cannot predict. That is the heart of the natural model. Not just heat, but pattern. Not just jetting, but uneven jetting. And the unevenness is key, because smooth, symmetrical jets are easy to model. You can calculate the direction of thrust, the change in speed, the effect on orbit, but 3i Atlas did not behave smoothly. Its jets behaved like they were dancing around a strangely textured nucleus. And here is where the analogy becomes almost comforting. Imagine a spinning ball with little vents scattered across its surface. Some vents are tiny, some are deeper, some are barely open. And as the ball spins, sunlight warms one region after another, activating some vents while shutting down others. The jets flicker, they turn, they amplify and diminish in rhythm with the rotation. And so the acceleration shifts, it bends, it behaves in ways that look unusual until you understand the messy, irregular geometry beneath. This is how Neucart's model managed to reproduce the observed non-gravitational acceleration without invoking anything beyond physics. It's not magic, it's not intention, it's messy nature doing what messy nature often does. But even so, the model left gaps. It solved the acceleration problem, yes, but it did not solve nickel without iron. It did not solve deep negative polarization. It did not solve the strangely low water content or the curious ecliptic alignment. The model was a lantern, not a floodlight. It illuminated one part of the puzzle while leaving the rest in shadow. And that That itself is a lesson, because science is not a machine that produces final answers. It is a process of continuously refining our understanding, not just adding new facts, but reshaping old assumptions. We grow older, clocks tick, and the universe reveals itself inch by inch rather than all at once. And uh, when you look at how the scientific community responded to 3i Atlas, you begin to see echoes of past mysteries. Pulsars were once mistaken for signals from intelligent civilizations. Fast radio bursts were once thought to be impossible within natural physics. Oumuamua was once considered too strange to be explained by outgassing until models of outgassing became more nuanced. Every time we bumped into something odd, the instinctive leap was toward the extraordinary. But every time, so far at least, nature managed to catch up. It's not that extraordinary explanations were wrong, it's that they were not needed, not yet. The universe often saves us from our own imagination by being more intricate than we assumed, not just more complex, but more diverse. It's not that 3i Atlas behaves impossibly. It's that it behaves in ways our models have never fully accounted for. And that, well, forces us to step back and ask ourselves what other assumptions might be limiting our view. The internal structure of an interstellar object is likely nothing like a typical comet. Consider how billion-year cosmic ray exposure could carve deep chemical layers. Consider how radiation could fracture the surface into fine grains that scatter light differently. Consider how volatiles could concentrate unevenly after eons of thermal cycling. So we begin to see that an interstellar object is not just a comet from another star, but a survivor of a harsher environment, a witness to long-forgotten stellar eruptions, galactic tides, and collisions we will never observe. And when you feed that kind of history into a thermophysical model, you begin to see why the behavior is so unusual. Ordinary comets are young compared to the age of the galaxy. Interstellar ones are not. They have lived long enough for their structure to diverge in ways so deep that our solar system training wheels no longer apply. And that is the beauty hidden in Newcart's approach. The model does not pretend to know the true internal configuration of 3i Atlas. It acknowledges that we cannot know. Instead, it embraces the uncertainty. It lets thousands of possibilities unfold. It treats the object not as something simple, but as something layered, ancient, and complex. And this is where the philosophical undertone gently slips into place. Because the struggle to understand 3i Atlas echoes a broader truth. The universe rarely presents itself in fully solvable puzzles. More often, it hands us fragments. And the fragments ask us to imagine the whole without ever guaranteeing that we will get it right. Sometimes, well, even the best natural explanations leave room for mystery. Not supernatural mystery, not speculative mystery, but the kind of mystery that arises when the data points toward a story we cannot fully reconstruct. And that tension between explanation and ambiguity is part of what makes science a human endeavor. We want to know, we want certainty, we want the puzzle to resolve into a clear picture. But objects like 3i Atlas remind us that nature does not answer to our desire for closure. It reveals what it reveals and hides what it hides, still. So the model gives us something precious. It shows that at least the non-gravitational acceleration can emerge from natural causes. It shows that the object need not be controlled, need not be crafted, need not be anything more than a deeply weathered fragment of cosmic geology. And in doing so, it brings the story back into the realm of the possible, even as the other anomalies continue to tug at the edges of our understanding. And this brings us to a deeper reflection. Sometimes a single explanation solves one part of a mystery while leaving others untouched. And that is how progress happens. Not with a single unifying theory, but with a mosaic of partial answers that gradually coalesce. But the story does not end here, because even if physics can explain the acceleration, we are left with questions about the surface, the chemistry, the long history buried within those layers of dust and fractured ice. And that is where the next path opens, the path that leads us into the aging of interstellar objects, into the slow sculpting by cosmic rays, into the long geological sleep that transforms a world over billions of years. And, well, as we turn from the internal modeling toward the surface itself, toward the scars left by cosmic radiation and the strange chemistry that emerges over deep time, we find ourselves stepping naturally into the next chapter. The chapter where the surface becomes a record, where 3 billion years alone in the dark begin to speak, and where the mysteries of 3i Atlas reflect not just anomalies, but the long, patient hand of cosmic aging. Well, when we turn from the inner mechanics of outgassing toward the outer skin of 3i Atlas, we step into a territory shaped not by moments or years, but by billions of years of cosmic weather. And, well, the idea alone feels almost overwhelming. Because as strange as the object's orbit and anomalies may seem, it is the surface itself that carries the deepest scars, the oldest memories, the slow, patient transformations that only the galaxy can carve. And it is here, on that ancient crust, that some of the most revealing clues begin to emerge. You see, interstellar space is not empty. We imagine it as a vacuum, a nothingness, stretching between stars. But in truth, the galaxy is soaked in high-energy particles, cosmic rays accelerated by supernovae, by stellar winds, by magnetic fields twisting through the interstellar medium. These particles strike any object drifting through that darkness with energies high enough to break apart molecules, rearrange atoms, fracture bonds, and over millions of years, well, over billions, the effect becomes profound. So imagine 3i Atlas beginning its journey, perhaps as a more ordinary cometary body, ice-rich, volatile, covered in the familiar chemical signatures of its native stellar system. Now imagine 3 billion years of exposure to galactic cosmic rays. That amount of time is almost impossible for us to feel. We grow older, clocks tick, but nothing in human experience maps onto geological timescales in interstellar space. Yet in that unimaginable span, the radiation dose accumulates, layer upon layer. The outermost molecules crack first. Ices darken as carbon chains reorganize. Simple compounds break apart, recombine, and reassemble into tholins, those complex reddish materials seen on bodies like Pluto and Triton. And as the radiation burrows deeper, it forms a crust, not just a thin skin, but a thick, processed mantle, possibly tens of meters deep, a shell of chemically altered material that seals the inner volatiles away like a coffin wall. And, well, that crust explains several of the object's peculiar traits. The deep reddish coloration observed from Earth, for instance, is exactly what we would expect from a surface cooked by cosmic rays for immense spans of time. Photons and particles rearrange the structure of carbon-rich compounds, turning them into pigments that absorb blue light more strongly. It's not that the color tells us where the object came from. It's that the color tells us how long it has been wandering. Time writes itself in red. But it's not just color, it's composition. Observations suggested unusually high levels of carbon dioxide and unexpectedly low levels of water. And at first glance, this seems counterintuitive. Why would water be depleted while carbon dioxide remains? But the answer may lie in the penetration depth of cosmic rays. Water ice, when struck, breaks into fragments that can escape more easily, especially through microcracks. CO2, meanwhile, can become trapped in the processed crust or reformed chemically within its fractures. So what we see is not the material the object was born with, but the material that has survived its crossing of the galaxy. The outer layers are a history book, but a distorted one. Pages torn, words rewritten, chapters missing. This becomes even clearer when we compare 3I Atlas to 2I Borisov, the second confirmed interstellar object. Borisov was rich in pristine ices, almost untouched, suggesting it had not wandered long between stars. Its surface appeared young, clean, its chemistry familiar, but 3I Atlas is nothing like that. It is old, scarred, sculpted by eras so long they feel geological rather than cometary. And that contrast between them raises a question that scientists are only beginning to articulate. Are there categories of interstellar objects shaped by different cosmic ages? It's not a simple question, because if 3I Atlas has been drifting for billions of years, then its surface may represent an entirely new class of processed interstellar bodies, a kind of cosmic relic altered beyond recognition. And such a surface could explain the deep negative polarization detected. When light scatters off extremely fine, radiation shattered grains, the polarization pattern changes, not just a little, but dramatically. The negative value, near minus 2.7%, could indicate a surface made of grains that have been ground down microscopically by radiation and thermal cycling. This is where the metaphor of a natural camouflage begins to arise, not because the object intends to hide, but because its surface has been transformed into something that obscures its origins. It is not just weathered, it is disguised by time itself. The chemical fingerprints erased, the isotopic signatures blurred, the structure altered until what remains is more a product of the galaxy than of the star system where it began. And, the idea of a natural camouflage leads us towards something deeper, something more philosophical. If interstellar objects are shaped so profoundly by their journeys, then perhaps their individuality is swallowed by the cosmos. They become, in a sense, anonymous travelers, not just from somewhere, but also from everywhere. Time erases the tracks behind them. But even so, some features linger. The odd carbon monoxide levels, for example, may point toward a region of formation with heavy CO abundances, such as the cold outer disks of young star systems. The low water could signal an origin in environments where water either never condensed or was quickly lost. And when you combine these clues with surface processing models, a picture begins to form, though still blurred. It suggests a birthplace fundamentally different from our solar system, perhaps around a faint star that emitted weak radiation, perhaps around a system with high concentrations of refractory material, or maybe in a cluster where newborn stars stripped volatiles aggressively from nearby planetesimals. The surface, even distorted, whispers of a history beyond our maps. Now, the effects of cosmic rays go deeper than chemistry. They also restructure the mechanical properties of the surface. As radiation fractures material, it becomes porous, crumbly, and insulating. The deeper layers may remain volatile rich, but the outer crust grows harder, drier, and more brittle. And this could explain why outgassing jets behave so unevenly. Cracks open in unpredictable patterns. Volatiles escape through tiny vents rather than broad regions. This uneven surface also reshapes thermal flow. Sunlight warms one spot, but the heat does not spread easily. The crust becomes a patchwork of hot and cold zones. And the resulting temperature gradients drive localized sublimation rather than smooth evaporation. So the jet behavior we described earlier becomes easier to understand once we imagine this strange ancient shell. But perhaps the most profound implication of surface aging is that it creates objects that no longer resemble anything in our solar system. They are chemically unique, mechanically unique, optically unique. And that means our theories built on comets begin to falter. Not because the universe is strange, but because our sample size is small. Interstellar objects expand our sense of what is possible. So the question naturally arises, does 3I Atlas represent a new category of cosmic debris? Something weathered so deeply that it challenges our definitions? Or is it simply the extreme end of a spectrum we have only begun to see? We do not yet know. But its surface hints at a diversity in interstellar populations more vast than our early observations suggested. It's not that interstellar bodies are exotic, it's that they carry the marks of journeys so long that even their atoms have forgotten where they came from. And that brings us to something subtle, something that takes time to fully appreciate. When we look at 3I Atlas, we are not just seeing an object, we are seeing time itself, time made physical, time made visible. Cosmic rays acting like a sculptor whose chisel is made of pure energy. The irony, of course, is that the more time transforms such an object, the harder it becomes to trace its origins. The surface becomes a mask, a natural disguise. And the science becomes not just a study of chemistry, but a study of forgetting, the forgetting of its birthplace, the forgetting of its early structure, the forgetting of the star that once warmed it. But even in this forgetting, there is beauty, because the universe does not just build, it erases, it reshapes, it renews. And in that cycle of creation and destruction, we find a deeper truth, that nothing in the cosmos remains as it was. Not stars, not planets, not solitary travelers like 3I Atlas. And not us. We change, we age, we weather our own invisible cosmic rays. So as we consider this 3 billion year transformation, we feel ourselves being pulled gently toward the next question. If this object is so shaped by time, if its surface tells a story of erasure and endurance, then what does its future hold? What path does it follow now that it has brushed past our sun? And where does such an ancient traveler go next? And, this leads us naturally into the next part of our journey, where we step away from what 3I Atlas is and turn toward where it is heading, drifting outward into the gulfs between stars, carried by momentum, by history, by forces set in motion long before our world existed. Well, when we follow 3I Atlas past the sun and out toward the great dark again, something shifts in the tone of the story. Up to now, we have been examining what it is, how it behaves, how its strange chemistry and ancient surface whisper about its past. But now we stand behind it, watching it drift farther and farther from our star, and the question becomes softer, more philosophical. Not just what it is, but where it is going. Not just why it behaves strangely here, but what this long, cold journey across the galaxy actually means. And That shift is important because the trajectory of an interstellar object is more than a line drawn against a star chart. It is a memory of forces acting across cosmic time. It, it is the one thing about 3i Atlas that has been preserved through all the erosion, all the radiation, all the cracking and reshaping of its body. The orbit is the last echo of the moment it was pushed out from its birthplace. And so when we ask where it's headed, we are not really asking about the future. We are asking about the fossil of a moment billions of years old. You see, after leaving our sun behind at roughly 40 kilometers each second, 3i Atlas is now on what astronomers call an escape trajectory. It has no intention of circling back. Once it passed perihelion, the closest point to the sun, the gravitational pull weakened with every kilometer, and with its speed, with its hyperbolic excess velocity, nothing remains to bind it. It is free, entirely free, and the freedom is not something it gained here, it is something it has carried for ages. The refined orbital vector, traced by observers in 2025, pointed toward a region connected loosely to the Gould Belt. And if you imagine the Gould Belt as a sort of gentle ring of star-forming regions, tilted relative to our galactic plane, then placing 3i Atlas on a trajectory pointing toward it becomes an exercise not just in geometry but in wonder, because the Gould Belt itself is ancient and mysterious, populated with bright young stars, clouds of gas, pockets of dust. It's not that 3i Atlas is heading to a destination, it's that its path happens to align with a region rich in stellar history. And, well, that is the key. In celestial mechanics, objects do not aim, they do not choose. They follow the consequences of forces long forgotten. The trajectory of 3i Atlas may suggest purpose, but purpose is a projection, not just something we imagine, but also something we yearn for. It's not traveling to the Gould Belt. It's simply passing through the galactic architecture that shapes the motions of countless bodies like it. Even so, when you trace its outbound path, letting the simulation run forward thousands of years, millions of years, the picture becomes almost poetic. It will slip away from the outer planets, cross the region beyond the heliopause, drift into the interstellar medium, and eventually rejoin the slow population of debris drifting between the stars. And that journey will continue so long that our own civilization will have risen and fallen many times over. Stars we know today will have shifted across the sky. The Milky Way itself will have rotated subtly around its center, and 3i Atlas will simply keep going. It is humbling because, in a deep sense, the object is not traveling through space, it is traveling through time. It carries with it a piece of a past none of us can touch, and a future none of us will see. And so when we ask again, where is it going? The answer is beautifully simple. It is going forward, forward into the galaxy, forward along a path set in motion by events older than our world. But the real question, the one that sits behind that surface level inquiry, is why do we care where it is going? Why does the trajectory of a wandering shard provoke something almost emotional in us? Perhaps it's because in watching something leave, we realize how brief our encounter really was. It spent billions of years in darkness, then passed through our solar system for only a flicker of cosmic time, days, weeks, and then it left again. That contrast between the vastness of its journey and the brevity of our glimpse reminds us of our own smallness. We grow older, clocks tick, but even our entire lifetime is nothing compared to the orbit of a single wandering body. And well, perhaps that moment of humility opens a different kind of curiosity. If 3I Atlas is not coming to us, then where is it ultimately drifting? Will it pass near another star in 10 million years? Will it brush through a cloud of interstellar dust that slowly reshapes its surface once more? Will it remain intact or crumble into fragments after some unnoticed collision in the dark? Scientists simulate these things sometimes, tracing the possible outcomes of an interstellar traveler. Most likely, it will simply continue its slow spiral around the galaxy, not in orbit around any one star, but in orbit around the galactic center. The sun does this too, all stars do, and all the debris between stars joins in this great slow dance. So, so even though 3I Atlas appears free, in a sense it is still bound to the Milky Way's gravity, pulled subtly by the mass of billions of stars. But the interesting part comes when we think about the next star it might encounter. The galaxy is not static. Stars move, systems drift, and an object like 3I Atlas could, over millions of years, wander into the outskirts of some other solar system. It might skim the gravitational reach of a passing star. If the motion is just right, it may be captured temporarily, or flung into yet another trajectory, or smashed into dust in the disk around a young sun. The future is a branching tree of possibilities, none more likely than the others. Yet, in all these futures, one thing remains constant. The journey is long, much longer than anything we, as humans, can imagine. The distances between stars are so vast, the timescales so immense, that even traveling at dozens of kilometers per second feels like stillness. And that contrast between speed and immensity is one of the quiet truths of astrophysics. Motion becomes relative, meaning becomes relative, purpose becomes something we project onto things that do not need purpose. And this brings us back gently to the idea raised earlier. What if the object were guided? What if the anomalies hint at something more? Some wondered whether the alignment, the unusual chemistry, the acceleration might point toward artificial origin. But the more we study, the clearer it becomes that the anomalies likely arise from natural processes, not intentional design. The trajectory, too, supports this. It is not aimed at anything. It is the path of a body pushed long ago, a traveler without a destination. Yet even in rejecting extraordinary interpretations, something profound remains. The possibility that objects like this one are not merely geological curiosities, but interstellar messengers, not in the metaphorical sense of carrying messages, but in the scientific sense of carrying information, clues about environments far beyond our reach. And when we let that thought settle into the mind, it becomes strangely moving, because it means that the universe does communicate with us, not through signals, not through intention, but through the silent drift of matter. And, well, maybe that is why so many people felt captivated by 3I Atlas, even though it was small, faint, barely observable at times. It's not just a rock. It's a history book written in the language of chemistry, a time capsule that wandered into our solar system by chance. And now, as it leaves, it continues that ancient story far beyond our horizon. There is another way to think about this, and it is perhaps more intimate. It's not that the object is going somewhere, it's that it is returning to the fabric of the galaxy, returning to the environment that shaped it. In a sense, the solar system was just an interruption, a momentary intersection of paths. For us, that moment was astonishing. For the object, it was almost nothing. And that asymmetry is strangely beautiful. It reminds us that we are the ones who assign meaning. The universe simply moves, When astronomers projected its path outward over millions of years, they found that it would not come close to any major star soon. It would drift through sparse regions, crossing arms of the Milky Way, slowly, passively, and that emphasizes the randomness of its encounter with us. Had the Sun been slightly offset in its own orbit, had 3I Atlas passed 1 million kilometers farther outward or inward, we would never have known it existed. But randomness brought it close enough for our telescopes to catch it, a cosmic coincidence, a moment where two stories intersected. So what does this tell us about our place in the universe? Perhaps nothing directly, but perhaps everything indirectly. It tells us we are not the center. It tells us that we are part of a larger current, a flow of matter and energy across the galaxy. And every so often, a traveler passes through that flow and reminds us of the scale of things. There is also the matter of time. When we talk about millions or billions of years, it becomes easy to lose the thread. But if you imagine the galaxy as a vast ocean, then interstellar objects are like drifting pieces of driftwood. They float, they turn, they collide, they dissolve. And occasionally, one washes up on a beach it never meant to visit. That is what 3I Atlas did. It washed up on the shore of our solar system, and now the tide is pulling it back out. Yet we wonder, we always wonder, might it encounter another civilization somewhere in the distant future? Might some alien astronomers record its faint lights as it passes through their system? And if they do, what will they think? Will they see the same anomalies we saw? Will they run the same simulations? Will they ask the same questions about its path, about its chemistry, about its purpose? And, will they feel the same quiet awe at holding a tiny fragment of the galaxy's history in their instruments? It's not absurd to imagine this, because if our civilization lasts, if our telescopes improve, if our exploration deepens, we may one day intercept an interstellar visitor ourselves. Not just observe one, but reach out and touch it, drill into its surface, analyze its chemistry directly. And that possibility leads the mind naturally toward the chapter that will follow this one, the chapter about the future of studying these cosmic travelers. But before we drift toward that horizon, let's stay just a little longer with the idea of destination. Because the truth is subtle. It's not that 3I Atlas is heading towards something. It's that it is heading away from us, away from the Sunday, away from the brief moment when we could glimpse its nature. And in that departure, there is a strange reflection of our own longing. We want to follow it, not physically, not yet at least, but intellectually, spiritually even, because something about an ancient object slipping back into darkness pulls at a very human part of us, the part that wonders about origins, the part that wonders about endings, the part that looks into the night sky and feels both tiny and infinite. We grow older, clocks tick, and yet our curiosity remains young. And when we think about the trajectory of 3I Atlas, what we are really thinking about is the continuity of the universe, that everything moves, that everything transforms, that even a silent rock can carry stories across aeons. So as 3I Atlas drifts outward, as it becomes dimmer and dimmer in our telescopes, it leaves us with a final, gentle question. If it did not come for us, and it did not stay for us, then what place do we have in its story? And the answer, simple and profound, is this. We are just an intersection, a brief crossing of paths, not the center, not the purpose, just a moment. And that moment is enough, because now, as we turn from the question of where it's going toward the broader landscape of what comes next for us for our science, for our efforts to intercept and study future interstellar travelers, we find ourselves walking naturally into the next chapter. The chapter where we stop watching these objects passively and begin imagining how we might one day meet them out there in the deep and patient dark. Well, standing here at the quiet edge of everything we have traced so far, it feels as though 3I Atlas has already drifted into myth. Not myth in the sense of fantasy, but myth in the sense of something that lingers in the mind long after the object itself has vanished from sight. And, well, maybe that is the most fitting way to begin closing this long, wandering journey. Not with an answer, not with a solution, but with a recognition that the universe, in its vast indifference, sometimes gives us stories disguised as data. And it is up to us to decide what those stories mean. You see, after everything we have explored, the orbit, the anomalies, the surface, the ancient scars, the long escape into the dark, the truth remains beautifully unchanged. 3I Atlas did not come for us. It did not arrive with purpose, nor leave with sentiment. It simply passed by. A visitor moving on currents older than our species, shaped by collisions we never witnessed, carrying traces of environments we have never touched. And perhaps that indifference is what makes the encounter so strangely emotional. Because we want meaning, we want intention. We want the universe to look back at us, even if just for a moment. But objects like 3I Atlas teach us something gentler, something quieter, that the universe does not need to notice us for us to find wonder in it. It's not looking down at us, it's inviting us to look up. When scientists in 2025 pieced together the last fragments of its light curve, the last whisper of its trajectory, they spoke with a kind of scientific humility that is rare in an age so hungry for certainty. They said, simply, that much of the evidence supports a natural origin. They said that the anomalies, though puzzling, fall within the vast domain of what nature might produce across billions of years. And they said something else, something that feels, in a way, like the emotional center of this entire path we've walked together, that mysteries like this are valuable precisely because they resist closure. So what do we do with that? What do we do with a visitor that leaves behind more questions than answers? Well, maybe the right response is gratitude. Gratitude that in a galaxy so large, an object so ancient wandered close enough for us to notice. Gratitude that the encounter stretched our instruments, our theories, our imagination. Gratitude that even if we could not decode every piece of its nature, we were given the chance to try. And, well, perhaps the deeper meaning lies beneath that gratitude, a reminder that science is not a catalogue of certainties, but a conversation between what we observe and what we long to understand. Between the world as it is and the world as we imagine it could be, 3I Atlas, in its brief flicker across our telescopes, became part of that conversation. It asked us to reflect, to reconsider, to admit what we do not know. It also asked us to be humble, not just in the face of the unknown, but in the face of the unknowable, because some features of its history may be permanently erased, some chemical signatures too deeply altered, some origins too thoroughly hidden by time's patient hand. And that is a kind of beauty in itself. A beauty rooted not in revelation but in restraint. We grow older, clocks tick, and we come to realize that the universe owes us no explanations, yet it grants us glimpses short, delicate, fleeting. And in those glimpses, we find ourselves expanding, stretching our minds towards scales that dwarf us and yet somehow make us feel more connected, not less. So think of the 8 anomalies we traced earlier, each one a doorway into deeper questions, each one a reminder that nature is not tidy, that nature does not conform to the patterns we prefer. And whether it was the nickel without iron, the deep negative polarization, the faint anti-tail, the puzzling acceleration, well, whether it exists at all as a unified story is uncertain. But the combination forced us to step outside familiar frameworks, forced us to imagine possibilities we had not considered, forced us to accept that science grows most when faced with discomfort. And there is something quietly inspiring in that. It means that even within the small span of human life, even within our limited ability to sample the galaxy, the universe can still present us with an object so strange that we must pause, we must breathe, we must rethink. So perhaps the legacy of 3i Atlas is not its composition, nor its orbit, nor its destination, but the way it loosened our grip on certainty, the way it invited humility, the way it whispered that our models must always remain open, always remain willing to evolve. And while most lines of evidence lean toward a natural origin, the true significance lies not in confirming the ordinary, but in expanding our sense of what the ordinary can include. Natural does not mean simple. Natural does not mean familiar. Natural does not mean predictable. Nature, across cosmic time, is as creative as any storyteller. In that sense, this interstellar traveler becomes a teacher, not just teaching us about chemistry or dynamics or cosmic ray processing, but teaching us about our own limits, teaching us about patience, teaching us about wonder. And when we place its journey against the backdrop of human curiosity, something tender emerges, a kind of shared trajectory. It heads outward, further into the dark, and we, in our small way, head outward too, through telescopes, through missions, through imagination, not just outward into space, but also inward, into the part of ourselves that longs for connection with the cosmos. It's not out there, it's in here, this desire to understand. And that, perhaps, is the deepest link between us and an object that has never known we exist. Now, as the object fades, as the faint trace of its light dissolves into background dust, we are left with the pieces, the fragments, the unanswered questions. And these become the building blocks of future science, future missions, future generations who will look back and see 3i Atlas as one of the early members of a new field, the study of interstellar visitors. And this is where the forward momentum returns, because even though this visitor has left, others will come, and we will be ready, more ready than before, better instruments, faster missions, more imaginative models, and perhaps, someday, a probe that will meet one of these travelers in the quiet interstellar dark. It is worth remembering that this is only the beginning. In the span of cosmic time, 2017 to 2024, the era of Oumuamua, Borisov, Atlas, is just the first whisper of a field that will grow into something extraordinary. A field where humanity no longer watches interstellar objects from afar, but intercepts them, studies them, maybe even captures fragments of them. And from those fragments, new sciences will grow. So as we draw this long reflection toward its final breath, it becomes clear that 3i Atlas did not just pass through the solar system. It passed through our understanding. It passed through our imagination. And like any good teacher, it left before we were ready for it to go. But the story is not over, not just yet. Because now, having walked through its orbit, its anomalies, its surface, its journey, and its meaning for humanity's future, we find ourselves at the threshold of something even deeper. A question not about the object, but about us. What do encounters like this reveal about the human mind, about our longing, about our capacity for awe? And that is where the next chapter gently begins to take shape. A chapter where the universe becomes a mirror, where cosmic visitors reflect something essential about who we are, and where humility becomes not an end, but a beginning.